The morning light filtered through the blinds of the small office tucked away in the corner of Westlake University's mathematics building. Dr. Elena Patel sipped her tea, savoring the moment of quiet before her students would arrive for office hours. At 42, she had spent nearly 2 decades teaching at this modest state school, content with her life despite the fact that her brilliance often went unnoticed in the wider academic world. Elena ran her fingers through her graying hair and adjusted her simple glasses. Unlike many of her colleagues who chased prestige and recognition, she found joy in the everyday miracles of mathematics and in watching understanding dawn on her students' faces. Her office walls were covered not with awards or accolades, but with thank you cards from former students whose lives she had touched over the years. Another day, another equation, she mumbled to herself with a small smile as she reviewed her lecture notes for the day's calculus class. A knock at her door broke her concentration. "Come in," she called, expecting to see one of her students seeking help with homework. Instead, Dr. Robert Chen, the head of the mathematics department, stepped into her office. Tall and always dressed in impeccably pressed clothes, he carried himself with the confidence of someone who had graduated from an Ivy League school and never let anyone forget it. "Morning, Elena," he said, his voice carrying that slight tone of condescension she had grown used to over the years. "Did you see the email about the department meeting this afternoon? We need to discuss budget cuts again." Elena nodded. "Yes, I'll be there." "Good, good," Robert said, then paused, his eyes catching sight of the academic journal open on her desk. Reading about the Hamilton Prize problem, are you? Quite the buzz in the mathematics world right now." Elena glanced down at the journal. The prestigious Hamilton Institute had announced a competition to solve a mathematical theorem that had stumped experts for nearly 50 years. The problem involved complex patterns in prime numbers that, if solved, could revolutionize modern cryptography and data security systems. "Just curious," she replied with a shrug. "It's an interesting challenge." Robert let out a chuckle that made Elena's cheeks burn slightly. "Well, don't get your hopes up about solving it. The best minds at Harvard, MIT, and Oxford have been working on this for decades. Lou from Princeton has a team of 30 researchers and they've been stuck for years." He tapped the journal page. "They're saying it might be another decade before anyone cracks it. Anyway, see you at the meeting." After he left, Elena stared at the journal, reading through the problem statement again. Unlike Robert, she didn't see a mountain too high to climb. Instead, she saw patterns and possibilities. There was something about this problem that called to her, like a puzzle piece that might fit perfectly with some of the work she had been doing in her spare time. That evening, after teaching her classes and sitting through the tedious budget meeting where Robert talked over her twice, Elena drove home to the small house she shared with her mother. Since her father had passed away 5 years ago, Elena had moved back home to care for her mom, whose health was slowly declining. It wasn't the life she had imagined for herself in her 40s, but she faced it with the same quiet determination she brought to everything else. "How was your day, sweetheart?" her mother asked from her favorite armchair as Elena entered, carrying groceries. "The usual," Elena replied with a warm smile. "How about yours? Did you finish that book you were reading?" They chatted as Elena prepared dinner, her mother's stories about the neighborhood gossip a welcome distraction from the complex mathematical concepts constantly swirling in her mind. After dinner and helping her mother to bed, Elena finally had time for herself. She spread her papers across the kitchen table, the Hamilton Prize problem staring back at her. Most mathematicians approached it using computational brute force or by building on existing theoretical frameworks, but Elena had always seen mathematics differently. Where others saw abstract symbols, she saw shapes, colors, and patterns, a gift of perspective that had helped her throughout her career but had also marked her as somewhat unconventional in academic circles. "Let's look at you from a different angle," she whispered to the problem. On the page, for weeks, Elena fell into a routine. She taught her classes during the day, cared for her mother in the evening, and stayed up late working on the problem. She drew diagrams and patterns that covered every inch of the whiteboard she had installed in her home office. Her approach wasn't following any established methodology. Instead, she was building a bridge between number theory and geometric visualization that few had explored before. Her colleagues would have been surprised by her dedication. At the university, Elena was known as reliable but unremarkable, She published papers occasionally in decent journals but wasn't considered a mathematical powerhouse. At department functions, she was often left standing alone while others networked and boasted about their latest research breakthroughs. During one such gathering to welcome a new faculty member, Elena stood near the refreshment table, half listening to Robert brag about his graduate school days to the newcomer. "Dr. Patel," a voice said beside her, and Elena turned to see Dr. Lydia Wong, one of the few colleagues she considered a friend. "Hiding by the cookies again?" Lydia teased, grabbing a drink. Elena smiled. "You know me too well. What have you been up to lately? I haven't seen you in the faculty lounge much." "Just teaching and taking care of Mom," Elena replied, hesitating before adding, "And I've been looking at the Hamilton problem in my free time." Lydia's eyebrows shot up. "Really? That's ambitious." "Just for fun," Elena clarified quickly, not wanting to seem presumptuous. "It's a good brain exercise." "Well, be careful not to mention it around Robert," Lydia whispered, nodding toward their department head. "He applied for a grant to work on that problem and got rejected. Sore spot." That explained his dismissive attitude, Elena thought. As the weeks turned into months, Elena's kitchen whiteboard became a complex web of interconnected ideas. She had taken an approach that combined visual geometry with number theory in a way that felt natural to her but would have seemed strange to most of her peers. While caring for her mother one evening, an idea struck her so forcefully that she nearly dropped the laundry basket she was carrying. "Mom, I need to write something down," she said hurriedly, rushing to grab a pen and paper. Her mother smiled knowingly. "That's your math face, and why, go on. I know better than to get between you and a good idea." That night, Elena made a breakthrough that connected two seemingly unrelated aspects of the problem. She didn't realize she had been working for 6 straight hours until she noticed the sun beginning to rise. Exhausted but exhilarated, she finally went to bed, her dreams filled with dancing numbers and geometric shapes. The next day at the university, Elena found it hard to focus on her teaching. Her mind kept drifting back to her work from the night before. During her afternoon advanced calculus class, a student's question about pattern recognition triggered another insight. "Hold that thought," she told the bewildered student, furiously scribbling in her notebook as the class watched in curious silence. By the time the monthly faculty meeting rolled around the following week, Elena had filled 3 notebooks with calculations and diagrams. She brought one with her to the meeting, unable to tear herself away from the problem even for a couple of hours. As Robert droned on about department rankings and publication requirements, Elena found herself sketching a new approach in the margins of her meeting agenda. The voices around her faded as a pattern emerged in her mind with perfect clarity, like a constellation suddenly becoming visible in a night sky. She stared at her notebook, her heart racing. Could it really be this simple? This elegant? She quickly worked through a series of calculations, checking and double-checking her work. The pieces fit together with a precision that took her breath away. Around her, the meeting continued. Someone was complaining about parking permits. Another person was discussing the university's new online learning platform. But Elena was miles away, standing on the precipice of something momentous. What her colleagues didn't know, what they had never bothered to discover, was that beneath Elena's quiet exterior lay one of the most creative, mathematical minds of her generation. While they saw an ordinary professor who taught calculus to undergraduates, they missed the woman who saw mathematics as a living, breathing entity with secrets waiting to be unlocked. As the meeting drew to a close, Elena gathered her things, her mind still swimming with the implications of what she had just discovered. She caught Robert looking at her with mild irritation. "Did you hear anything I said about publication requirements, Elena?" he asked. She nodded absently. "Yes, of course. Good, because the university expects more from you this year. We can't all coast by just teaching." The old Elena might have shrunk under his criticism, but the woman who had just glimpsed the solution to one of mathematics' most challenging problems merely smiled. "I'm working on something now. Actually," she said quietly. "Well, let's hope it's better than your last paper," he replied dismissively. "We need to improve our department's reputation." Little did he know that the unassuming woman walking out of his meeting room was about to turn the mathematical world upside down, and it would take her just 47 seconds to prove it. The Hamilton Prize. Problem haunted Elena's thoughts day and night. 2 months had passed since she first read about it in that academic journal, and now her home office walls were covered with papers filled with calculations, geometric diagrams, and colorful sticky notes connecting different concepts. Her mother jokingly called it her beautiful mind wall, though Elena insisted there was a perfect order to the apparent chaos. "I'm heading to bed. Honey," her mother called from the hallway one evening, "don't stay up too late with your numbers again." Elena looked up from her desk and glanced at the clock, nearly midnight. She'd been working for 6 hours straight after coming home from teaching. "Just a little longer, Mom. I think I'm onto something." After hearing her mother's bedroom door close, Elena stretched and walked to the kitchen for another cup of tea. The house was quiet except for the ticking of the old grandfather clock that had belonged to her father. These late-night sessions had become her refuge, the time when she could fully immerse herself in the mathematical puzzle that was slowly revealing its secrets to her. Back at her desk, she stared at the core equation of the Hamilton problem. Where most mathematicians saw a computational nightmare requiring supercomputers and teams of researchers, Elena saw something different, a pattern with an almost musical quality to it, like a symphony waiting for the right conductor to bring all the instruments together. Her approach was considered outdated by many modern mathematicians. While her colleagues relied heavily on computational methods, Elena preferred working with pencil and paper, visualizing problems spatially in ways that computers couldn't. It was this unique perspective that made her an excellent teacher but had also kept her from being taken seriously in research circles, dominated by technical specialists. The next morning, Elena arrived at the university with dark circles under her eyes, but a renewed sense of purpose. She had made a small breakthrough overnight, nothing revolutionary yet, but a different way of looking at one aspect of the problem that might open new doors. As she unlocked her office door, she nearly bumped into Dr. Chen, who was walking past with Dr. Thomas Harris, the university's Dean of Sciences. "Ah, Elena," Robert said with forced politeness, clearly trying to make a good impression on the dean. "Have you met Dean Harris? He's visiting all the departments this week." "Not formally," Elena replied, shifting her heavy bag of student papers to shake the dean's hand. "It's nice to meet you, sir." "Dr. Patel teaches our undergraduate calculus sequence," Robert explained in a tone that made it sound like a lesser assignment. "One of our most reliable faculty members," the dean nodded politely. "I've heard good things about your teaching from students, Dr. Patel." "Thank you," Elena said. "I enjoy working with them." "Elena, the dean and I were just discussing the university's new initiative to raise our research profile," Robert interjected. "All faculty are expected to submit proposals for significant research projects by the end of the semester." Elena felt her stomach tighten. More pressure to publish when she was already stretched thin between teaching, caring for her mother, and her work on the Hamilton problem. "I'll keep that in mind," she said, trying to keep her voice neutral. After they left, Elena sank into her chair and let out a deep sigh. The academic game had never been her strong suit. The politics, the constant pressure to publish or perish, the emphasis on flashy research over quality teaching. Yet here she was, working on one of the most significant problems in modern mathematics, and she couldn't tell anyone about it for fear of ridicule. Later that day, during her advanced calculus lecture, Elena found herself using the Hamilton problem as an example to illustrate a concept to her students, careful not to mention she was actively working on solving it. "So you see," she explained, drawing a complex diagram on the whiteboard, "sometimes in mathematics, approaching a problem from an unexpected angle can reveal solutions that remain hidden when using conventional methods." A student in the front row, Priya, raised her hand. "Dr. Patel, isn't that the famous Hamilton problem you're using as an example?" "My brother's a grad student at MIT, and he says their whole department is working on it." Elena felt her cheeks warm slightly. "Yes, it is. It's a good teaching example because it connects several mathematical concepts we've been studying. Have you ever tried solving it yourself?" another student asked. The question hung in the air for a moment as Elena considered how to respond. "I've played around with it," she admitted finally. "It's a fascinating problem. You should totally enter that competition," Priya said enthusiastically. "The deadline's in 3 months, right?" "That's very kind, but there are thousands of mathematicians worldwide working on this problem," Elena replied with a small smile. "Now let's get back to today's lesson. That evening, as Elena graded papers at her kitchen table, while her mother watched TV in the living room, her phone buzzed with a text message from Lydia. "Check your email. Department Research Funds announcement. Deadline next week?" Elena groaned inwardly as she opened her laptop to check. Sure enough, there was an email from Robert announcing a small pool of department funds available for promising research projects. The catch: presentations would need to be made to a faculty committee in just 5 days. For a brief wild moment, Elena considered presenting her work on the Hamilton problem. The thought vanished as quickly as it had appeared. Her approach was too unconventional, too different from the kind of research Robert and the others respected. Besides, she wasn't ready to share her work yet. It was still developing, still fragile. Instead, she returned to grading papers, but her mind kept wandering back to the Hamilton problem. There was something there just beyond her grasp, like a word on the tip of her tongue. The next few weeks passed in a blur of teaching, committee meetings, and late nights working on the problem. Elena's mother noticed her growing exhaustion. "You're running yourself into the ground, Elena," she said one morning, watching her daughter gulp down coffee before rushing off to teach. "What's so important about this math thing anyway?" Elena paused, trying to find words to explain to someone who had never experienced the thrill of mathematical discovery. "It's like when Dad used to restore those old clocks," she said finally. "Remember how he'd spend weeks figuring out what was wrong? And then when all the gears finally lined up and it started ticking again, his face would light up." "It's like that." Her mother's expression softened. "He was always so proud of your math skills. Said you got the good parts of his tinkering mind, but none of the messiness." Elena smiled at the memory. Her father, a watchmaker by trade, had been the first to notice her gift for patterns and numbers when she was just a child. He'd never gone to college himself, but had made sure Elena had every opportunity to develop her talents. "I just need to see this through, Mom," she said quietly. "I feel like I'm close to something important." As the submission deadline for the Hamilton Prize drew nearer, Elena found herself waking up in the middle of the night with new ideas. She'd keep a notebook by her bed to scribble down thoughts before they could slip away. During her morning commute, she'd dictate observations into her phone's voice recorder. Even while shopping for groceries, she would sometimes stop in the middle of an aisle, struck by a new connection between concepts. One Saturday morning, while helping her mother in the garden, Elena had a moment of clarity about a particularly troublesome aspect of the problem. She dropped the trowel she was holding and ran inside to her office, ignoring her mother's confused calls. 2 hours later, she emerged, dirt still on her knees, but with a breakthrough that connected two seemingly unrelated aspects of the problem. For the first time, she could see the general structure of a possible solution taking shape. That night, as Elena sat on her back porch staring at the stars, a strange calm washed over her. Most mathematicians approached problems like the Hamilton with teams of researchers, sophisticated computer programs, and institutional support. She had none of those things, just her intuition, persistence, and a different way of seeing. And yet somehow, she felt she might succeed where others had failed. Not because she was smarter, but because she was looking in places others hadn't thought to look. The solution, she suspected, wasn't going to come from brute computational force, but from a fundamental insight about the nature of the problem itself. The next morning, Elena made a decision. She would submit her work to the Hamilton Prize competition, regardless of what her colleagues might think. She began organizing her notes, creating a coherent framework for her approach. It wasn't a complete solution yet. There were still gaps to fill and proofs to finalize, but the core insight was there, waiting to be developed. As she worked on her submission during every spare moment, Elena felt a growing sense of purpose. For years, she had been content to remain in the background, teaching her students and publishing modest papers. Now, for the first time in her career, she was reaching for something more. Whether she succeeded or failed, she would know she had dared to challenge one of mathematics' greatest puzzles with nothing but her unique perspective and quiet determination. And somehow, that already felt like victory. Elena shuffled into the monthly department meeting, clutching both her coffee mug and a notebook filled with her latest work on the Hamilton problem. Dark circles had taken up permanent residence under her eyes, but there was a new energy in her step these days. She'd made significant progress over the past week. finding connections that felt like stepping stones across a wide river. The department conference room was already half full. Dr. Chen stood at the front, arranging his presentation notes with his usual air of self-importance. Elena slipped into a chair near the back, nodding politely to a few colleagues but keeping to herself. These meetings were rarely productive, and she had learned to bring work to occupy her mind during the inevitable administrative droning. "Good morning, everyone," Robert began, once the room had filled. "We have several important items on today's agenda. First, I'd like to discuss the upcoming budget considerations for next fiscal year." Elena opened her notebook to her latest diagrams. She had been exploring a geometric interpretation of the Hamilton problem that no one else seemed to be considering. While most researchers were treating it as a purely computational challenge, she saw it as a problem of shape and structure. Her approach involved visualizing the mathematical relationships in three-dimensional space, finding patterns in how certain numerical sequences related to each other when mapped onto geometric forms. As Robert continued talking about budget allocations and departmental priorities, Elena's pencil moved across the page, sketching a new variation of her model. She was only half listening to the meeting, catching phrases like publication requirements and research funding without fully engaging. "And as you all know, the university is emphasizing research output this year," Robert was saying, his voice cutting through her concentration momentarily. "Dean Harris has made it clear that departments with higher publication rates will be prioritized for funding next year." Elena frowned slightly, drawing a more emphatic line in her notebook. The constant pressure to publish was part of why she had kept her work on the Hamilton problem private. True mathematical insight couldn't be rushed or forced to fit academic calendars and funding cycles. "Additionally," Robert continued, "I should mention that several faculty members haven't met their expected publication quotas for the past 2 years. His eyes flicked briefly toward Elena, and she felt a flush of embarrassment. She knew he was referring to her, among others. Her teaching evaluations were consistently excellent, but in the currency of academia, that counted for little compared to research output. As Robert moved on to discussing department website updates, Elena returned to her notes. There was something about the pattern she was mapping that wasn't quite right. She erased a section and redrew it, considering a different arrangement. The meeting droned on. Someone was now discussing changes to the curriculum committee. Elena's mind wandered deeper into her mathematical world, the voices around her becoming mere background noise as she focused on the problem. She had been stuck on one particular aspect for weeks, how certain prime number sequences behaved within her geometric framework. The pattern seemed almost right, but there was an inconsistency she couldn't resolve. She had tried dozens of variations, but none had fully clicked. Absently, she sipped her now cold coffee and stared at her diagram. What if she was approaching this from the wrong angle? What if instead of trying to force the numbers to fit her model, she adjusted the model to reflect what the numbers were actually doing? She sketched a quick revision, rotating her perspective on the geometric structure. That was better, but still not quite right. She chewed on her pencil, a habit from childhood that returned whenever she was deep in thought. "And finally, before we wrap up, let's discuss the upcoming conference schedule," Robert was saying. "Several prestigious mathematics conferences have submission deadlines approaching, and I strongly encourage everyone to consider presenting." Something in Robert's words triggered a thought in Elena's mind, though it had nothing to do with conferences. The word approaching echoed in her head as she stared at her diagram. What if these numerical sequences weren't just related, but were actually approaching each other in a specific way? She quickly drew a new diagram, her hand moving almost of its own accord. Instead of treating the number patterns as static structures, she began to visualize them as dynamic systems moving through space, their relationships shifting over time. As she worked, the voices and sounds of the meeting faded completely from her awareness. The mathematical landscape in her mind became more vivid than the physical room around her. She could almost see the shapes rotating and aligning, revealing connections that had been invisible before. Then it happened. In a moment of perfect clarity, the final piece fell into place. The pattern completed itself on her page, and Elena suddenly understood exactly how everything fit together. The solution to the Hamilton problem, or at least the key insight needed to solve it, was right there in front of her, sketched in pencil on ordinary notebook paper. Her hand froze. Her breathing stopped. Time itself seemed to pause as the magnitude of what she had just discovered washed over her. "Dr. Patel?" The voice seemed to come from very far away. Elena blinked, slowly returning to the conference room, to the meeting, to reality. "Dr. Patel, do you have something to add?" Robert was looking at her with mild annoyance. Several other faces had turned in her direction as well. "What?" Elena asked, her voice slightly dazed. "You gasped quite loudly," Robert said. "Is there a problem with the conference schedule?" Elena looked down at her notebook, at the diagram that represented a breakthrough that had eluded the world's top mathematicians for decades. She had solved it. In the middle of a mundane department meeting, while people discussed website updates and budget allocations, she had solved one of the most challenging mathematical problems of the century. "No," she said quietly, carefully closing her notebook. "No problem at all." "Very well," Robert said, clearly unimpressed. "As I was saying, the International Mathematics Symposium in Zurich has extended their submission deadline." Elena barely heard him. Her heart was pounding in her chest. She needed to check her work, to verify that what she thought she had discovered was real and not just a product of sleep deprivation and too much coffee. But deep down she knew. The feeling of rightness, of mathematical truth, was unmistakable. The meeting finally ended, and faculty members began gathering their things and filing out of the room. Elena remained seated, still stunned by what had happened. "Are you coming, Elena?" Lydia asked, pausing by her chair. "You look like you've seen a ghost." Elena managed to smile. "I'm fine. Just tired. I'll be along in a minute." After everyone had left, Elena reopened her notebook and stared at the diagram. She took out her phone and checked the time. The entire breakthrough had occurred in just 47 seconds. Less than a minute to solve what countless mathematicians had struggled with for years. She carefully took a photo of her work, then another and another, afraid somehow that it might vanish if she didn't preserve it. Then she packed up her things and walked slowly back to her office, feeling as though she was moving through a dream. Once inside with the door closed, Elena spread her notes across her desk and began working through the solution step by step, verifying each component, each connection. Hours passed as she translated her geometric insight into formal mathematical language, creating a rigorous proof that would stand up to the scrutiny of the world's top minds. By late afternoon, she was confident. The solution was real. Her approach, visualizing the problem geometrically rather than attacking it computationally, had revealed pathways that others had missed. The implications were enormous, not just for solving this particular problem, but for entire branches of mathematics and computer science. Elena sat back in her chair, suddenly aware of how exhausted she was. She should feel elated, triumphant, but instead she felt a strange mixture of disbelief and calm. She had done it, but what came next? The Hamilton Prize submission deadline was still weeks away. She had time to refine her proof, to make it absolutely watertight. But part of her wanted to share her discovery immediately, to tell someone who would understand its significance. She picked up her phone, then set it down again. Who would she call? Her colleagues in the department would likely be skeptical, especially Robert, who had dismissed the possibility of anyone solving the problem anytime soon. Her friends outside academia wouldn't grasp the importance. Her mother would be proud but wouldn't understand the mathematics. In this moment of her greatest achievement, Elena found herself alone with her discovery. As the reality of what she had accomplished slowly sank in, a smile spread across her face. It didn't matter if no one else knew yet, she knew. In a plain conference room during a boring department meeting, she had seen something beautiful and true that no one else had seen before. And soon the world would see it too. She gathered her notes carefully, placing them in a folder that she tucked securely into her bag. Tomorrow she would begin preparing her formal submission to the Hamilton Prize Committee. But tonight she would go home and tell her mother that she had done something remarkable, even if she couldn't explain exactly what it was. As she left her office and walked through the quiet evening campus, Elena felt lighter than she had in years. The stars were coming out overhead, constants in an ever-changing universe, just like the mathematical truths she had spent her life exploring, and one of which she had just revealed to the world. The Hamilton Prize submission system was surprisingly simple, just an online form with fields for contact information, academic credentials, and a space to upload the solution paper. Elena hesitated before clicking the submit button. her finger hovering over the mouse. 2 weeks had passed since her breakthrough moment in the department meeting. 2 weeks of checking and rechecking her work, refining her proof, and making sure every step was clear and irrefutable. Still, doubt crept in. What if she had made a fundamental error? What if her approach was flawed in some way she couldn't see? She was, after all, a teaching professor at a modest state university, not a research powerhouse from MIT or Princeton. Stop it, she whispered to herself. The math is either correct or it isn't. It doesn't care where you work. Taking a deep breath, she clicked submit. A confirmation page appeared thanking her for her submission and explaining that all entries would be reviewed by the Hamilton Prize Committee, with results announced within 6 weeks. 6 weeks. A month and a half of waiting and wondering. Elena closed her laptop and leaned back in her chair. She had told no one at the university about her submission, not even Lydia. Only her mother knew, though she didn't understand the mathematics involved, just that Elena had solved a difficult problem that mattered to her. The next few weeks passed in a strange blur. Elena taught her classes, attended faculty meetings, and tried to carry on as usual while constantly fighting the urge to check her email every 5 minutes. The Hamilton Prize Committee wouldn't contact her unless her solution warranted further review. But that didn't stop her from hoping. 3 weeks after her submission, Elena was grading papers in her office when there was a knock at her door. "Come in," she called, expecting a student. Instead, Dr. Chen entered, looking unusually serious. "Elena, do you have a moment?" "Of course," she said, setting aside her grading. "What can I help you with?" Robert closed the door behind him and took a seat across from her desk. "I received an unusual email this morning," he said, his tone measured. "From Dr. Catherine Lin at the Hamilton Institute." Elena felt her heart skip a beat. Catherine Lin was the chair of the Hamilton Prize Committee. "Oh?" she managed, trying to keep her voice neutral. "Yes," Robert continued, watching her closely. "She wanted to verify that you are indeed a member of our mathematics faculty. Apparently you've submitted a solution to their prize problem." There was an unspoken question in his words, a hint of disbelief that bordered on accusation. "That's right," Elena said simply. "I did." Robert's eyebrows rose slightly. "I see. And you didn't think to mention this to the department, or to consult with colleagues who might have provided valuable input?" Elena felt a flash of annoyance. "The competition rules allow for individual submissions, Robert. And frankly, I wasn't sure my approach would be taken seriously here." "What approach is that exactly?" "A geometric visualization framework that reveals pattern connections not visible through purely computational methods." Even as she spoke, Elena knew how unconventional it sounded. Robert leaned back in his chair, his skepticism evident. "Elena, you do understand that the Hamilton problem has stumped the world's leading mathematicians for decades? Teams with supercomputers and massive resources have made little progress. I'm aware of that. And you believe you've solved it? Alone with geometric visualization?" The condescension in his voice was unmistakable. Elena straightened in her chair. "Mathematics isn't about resources or titles, Robert. It's about seeing patterns and connections. Sometimes a fresh perspective is exactly what's needed." Robert sighed as if dealing with a stubborn child. "I've responded to Dr. Lin confirming your position here. But Elena, I have to say I'm concerned about how this might reflect on the department if your submission is, well, not what they're looking for." The implication stung, but Elena kept her expression neutral. "I understand your concern, but my work stands on its own merits." After Robert left, Elena sat at her desk, a mix of emotions washing over her. She hadn't expected the Hamilton Institute to contact her university so quickly. What did that mean? Were they taking her submission seriously, or just verifying her credentials before dismissing her work? She didn't have to wait long to find out. The next morning, an email arrived from Dr. Catherine Lin herself. "Dear Dr. Patel," it began, "the Hamilton Prize Committee has conducted a preliminary review of your submission. Your approach is unconventional and warrants further examination. We would like to schedule a video conference with you to discuss certain aspects of your proof in greater detail. Please advise your availability for next week." Elena read the email 3 times, her hands trembling slightly. They were taking her seriously enough to want to talk to her. It wasn't a rejection, at least not yet. She responded with her availability and spent the next few days in a state of nervous anticipation, rehearsing explanations for the trickier parts of her proof, and preparing to defend her approach. When the day of the video conference arrived, Elena set up her laptop in her office, closed the door, and tried to calm her racing heart. At precisely the scheduled time, the call connected, and she found herself facing not just Dr. Lin, but 4 other members of the Hamilton Prize Committee, all renowned mathematicians whose work she had studied and admired for years. Dr. Patel, Catherine Lin began, her face serious. Thank you for joining us today. We have reviewed your submission and have several questions. What followed was 2 hours of intense mathematical discussion. The committee members took turns challenging different aspects of her proof, testing her understanding and questioning her methodology. Elena defended her work point by point, explaining her reasoning with growing confidence as she saw them engaging seriously with her ideas. Your geometric approach is certainly unusual, said Dr. Hiroshi Tanaka, a committee member from Tokyo University, but I'm particularly interested in how you made the connection between these seemingly unrelated sequences on page 17. Elena explained her insight, using the whiteboard in her office to sketch the 3-dimensional structure she had visualized. She could see the spark of understanding in Dr. Tanaka's eyes as he nodded slowly. Ingenious, he murmured. Unorthodox, but ingenious. As the questioning continued, Elena realized something important was happening. They weren't dismissing her work outright. They were testing it, challenging it, treating it as a serious contender. Finally, after exhaustive examination of her proof, Dr. Lin spoke. Dr. Patel, we appreciate your time today. Your solution contains elements that are highly original. We will need to verify your results independently, of course, but I must say, your approach offers a perspective that none of us had considered. Elena nodded, not trusting herself to speak. We will be in touch, Dr. Lin concluded, ending the call. Elena sat in her silent office, emotionally and intellectually drained. She had held her own with some of the finest mathematical minds in the world. Whatever happened next, that knowledge gave her a quiet sense of validation. The next 2 weeks passed in a strange limbo. Elena hadn't heard anything further from the committee, and she began to wonder if they had found a fatal flaw in her work that she had missed. She tried to focus on her teaching and other responsibilities, but the waiting was excruciating. Then, on a rainy Tuesday afternoon, Elena received another email from Dr. Lin. Her heart pounding, she opened it. Dear Dr. Patel, after thorough examination and verification of your submission, the Hamilton Prize Committee has determined that your solution to the problem is correct. The elegant geometric framework you developed provides not only the answer we sought, but opens new pathways for research in several related fields. This is a remarkable achievement. As is customary with breakthroughs of this magnitude, we request your presence at the Hamilton Institute's annual conference next month to present your solution. This will allow the broader mathematical community to engage with your work. Please confirm your willingness to attend. Congratulations, Dr. Patel. Your contribution to mathematics will be long remembered. Elena read the email again and again, scarcely believing the words. They had verified her solution. They thought it was correct. More than that, they called it remarkable, a breakthrough. She had done it. Actually done it. With shaking hands, she called her mother. Mom, remember that math problem I was working on? They say I solved it. They want me to present it at a big, conference. Her mother's proud reaction, loud exclamations of joy followed by immediate questions about what she would wear to the conference, made Elena laugh through tears of relief and happiness. The news spread quickly through the mathematics department. By the next morning, Elena's typically quiet office had become a hub of activity, with colleagues stopping by to offer congratulations. Some sincere, others clearly stunned that she, of all people, had achieved such a feat. Robert Chen's reaction was particularly telling. He appeared at her door with a forced smile. Elena, this is unexpected. Congratulations. Thank you. Robert, she replied simply. The department will certainly benefit from the attention this brings, he added. Already thinking of the institutional advantages. We should discuss how to leverage this in our next funding proposal. Elena just nodded, unsurprised by his focus on departmental politics rather than the mathematics itself. As word of her achievement spread beyond the university, Elena began receiving emails and calls from mathematicians around the world, all eager to understand her approach. Journalists requested interviews. The university president issued a glowing press release, suddenly proud of the quiet professor few had noticed before. Through it all, Elena maintained a sense of calm. The validation was sweet, yes, but it wasn't why she had pursued the problem in the first place. She had done it because she saw a pattern no one else had seen, because the problem had called to her, because solving it had been its own reward. As she prepared for the Hamilton Institute conference, organizing her presentation and planning how to explain her insights to the world's mathematical elite, Elena felt a quiet confidence she had never known before. She had always been a teacher at heart, finding joy in helping others understand. Now she would teach the teachers, share her vision with those who had never thought to look where she had looked, and perhaps, just perhaps, they would finally see her. The Hamilton Institute stood like a temple to mathematics, all clean lines and perfect angles, its modern glass and steel structure reflecting the clear blue sky. Elena paused at the bottom of the wide steps leading to the entrance, taking a moment to steady her breathing. Inside that building, hundreds of the world's most brilliant mathematical minds were gathering for the annual conference, and she was about to present her solution to them all. "You've got this," she whispered to herself, clutching her presentation folder a little tighter. Her mother had wanted to come for moral support, but Elena had gently discouraged her. This was a highly technical conference, and her mother would have been bored and out of place. Instead, they'd agreed she would come to the award ceremony the following evening, if things went well today. As Elena climbed the steps, she spotted Dr. Catherine Lin waiting in the lobby. The committee chair smiled warmly as Elena approached. "Dr. Patel, welcome to the Hamilton Institute. I'm so glad you could make it." "Thank you for having me," Elena replied, trying to keep her voice steady. "I admit I'm a bit nervous," Catherine nodded understandingly. "That's perfectly natural. But remember, your work has already been verified by the committee. You're not here to defend it, you're here to share it." That subtle distinction helped ease some of Elena's anxiety. Yes, she was here to share her insight, to teach, and teaching was what she did best. Catherine led her through the bustling lobby, where clusters of mathematicians were engaged in animated conversations. A few heads turned as they passed, and Elena caught snatches of whispers. "That's her," and Hamilton's solution and geometric approach. Word had clearly spread. They arrived at a small preparation room adjacent to the main auditorium. Inside, several other committee members were waiting, including Dr. Tanaka, who had been particularly interested in her approach during the video conference. "Dr. Patel," he greeted her with a respectful bow, "I've been working through your methodology again. The elegance of your geometric framework is truly remarkable." "High praise coming from you, Dr. Tanaka," Elena replied with genuine humility. His work on computational mathematics was legendary. "I must confess," he continued, "I would never have considered visualizing the problem in three-dimensional space. We've become so reliant on computational approaches that sometimes we forget to simply see." For the next half hour, Elena reviewed her presentation with the committee members, addressing a few last-minute questions and making minor adjustments to her slides. As the start time approached, Catherine checked her watch. "It's time," she announced. "The auditorium is full. Everyone is eager to hear from you, Dr. Patel." Elena took a deep breath and followed Catherine through a side door onto the stage. The auditorium was indeed packed, row after row of attentive faces all turned toward her. At the front, she recognized some of the most prominent names in mathematics, people whose papers she had studied throughout her career. In the middle rows sat younger researchers and graduate students hungry for new ideas. And in the back, she spotted a few familiar faces from her own university, including Robert Chen, who had apparently decided this was too significant to miss. Catherine stepped up to the microphone first. "Ladies and gentlemen, welcome to the highlight of this year's conference. As you know, the Hamilton Prize problem has challenged mathematicians for decades, with many believing it might remain unsolved for years to come. Today, we have the honor of hearing from Dr. Elena Patel, who has not only solved this problem but has done so with an approach that opens new pathways for mathematical exploration." A murmur ran through the crowd, part excitement, part skepticism. Elena could feel the weight of hundreds of analytical minds. Ready to dissect her every word, Catherine continued, Dr. Patel is a professor of mathematics at Westlake University, where she has taught for nearly 20 years. Her solution to the Hamilton problem came not from massive computational resources or large research teams, but from a unique geometric perspective that many of us had overlooked. Please join me in welcoming Dr. Elena Patel. The applause was polite but reserved as Elena took the podium. She adjusted the microphone, took a sip of water, and looked out at the sea of faces. "Thank you, Dr. Lin," she began, her voice steadier than she had expected. "For decades, the Hamilton problem has been approached primarily as a computational challenge, something to be solved through brute force calculation or increasingly complex algorithms." She clicked to her first slide, showing the traditional representation of the problem. But what if we've been looking at it wrong? What if, instead of seeing it as a problem of calculation, we see it as a problem of shape and pattern? For the next 10 minutes, Elena walked the audience through her approach, starting with the basic principles and building toward her breakthrough insight. She explained how visualizing the number sequences as three-dimensional structures revealed connections that remained hidden in traditional formats. She showed how certain mathematical relationships became obvious when viewed from the right angle, literally. As she spoke, she could see the expressions in the audience changing. Initial skepticism gave way to curiosity, then to dawning understanding. When she described the key insight that had come to her during that departmental meeting, she saw several prominent mathematicians sit forward in their seats, their eyes widening. The solution, therefore, isn't found through more powerful computation, Elena explained, showing her final diagram, but through recognizing this fundamental pattern relationship, which once seen can be verified through relatively simple mathematics. She clicked to her final slide, showing the formal proof in all its elegant simplicity. "And that's it," she concluded. "The Hamilton problem yields not to force but to perspective." For a moment, complete silence filled the auditorium. Elena's heart pounded in her chest. Had she failed to explain clearly? Had she made some error she hadn't caught? Then from the front row, Dr. Alejandro Rivera, a Fields Medal winner whose work had defined modern number theory, slowly stood up. He looked at Elena with an expression of pure mathematical appreciation, then began to applaud. Like a wave, the applause spread through the auditorium, growing louder and more enthusiastic. Soon the entire audience was on their feet, the skepticism completely gone, replaced by the pure joy that mathematicians feel when presented with an elegant truth. Elena stood at the podium, overwhelmed by the response. This wasn't just professional courtesy. This was genuine recognition from a community that valued truth above all else. They had seen her solution, understood it, and recognized its beauty. The standing ovation continued for nearly a minute before Catherine returned to the microphone, beaming with satisfaction. "I believe we have time for a few questions," she announced as the audience finally returned to their seats. Dozens of hands shot up immediately. Catherine pointed to Dr. Rivera first. "Dr. Patel," he said, his voice carrying the slight accent of his native Spain, "your geometric approach is brilliantly unconventional. Have you applied similar visualization techniques to other unsolved problems?" "Not yet," Elena admitted, "but I believe this framework could be adapted to several other challenges, particularly in prime number theory." Another prominent mathematician asked, "How did you come to consider a three-dimensional approach when most of us have been working in computational spaces?" Elena smiled slightly. "I've always thought visually. When I teach complex concepts to my students, I often use geometric analogies to help them understand. It seemed natural to apply the same approach to my research." The questions continued for nearly half an hour, all serious, respectful inquiries about her methodology, her insights, and the implications of her solution. No one questioned her credentials or expressed doubt about her results. The mathematics spoke for itself, and in that universal language, Elena had said something profound. After the session ended, Elena found herself surrounded by colleagues eager to speak with her personally. Young graduate students asked for her advice on their own research. Established professors who had never given her a second glance at previous conferences now sought her insights. Even Robert Chen approached, a strange mix of pride and chagrin on his face. "Remarkable presentation, Elena," he said. "The department is incredibly proud. We'll have to discuss adjusting your teaching load to give you more time for research when we get back." Elena just nodded, amused by his sudden change of heart. Later that evening, at a reception hosted by the Institute, Catherine Lynn found Elena by the windows, taking a quiet moment away from the constant stream of congratulations and questions. "How are you holding up?" Catherine asked, handing her a glass of champagne. "It's a bit overwhelming," Elena admitted. "Yesterday I was just a math professor from a small university. Today people are asking me to sign their conference programs." Catherine laughed. "That's how it goes in our field. One day you're working in obscurity, the next you're a mathematical celebrity." She clinked her glass against Elena's. "Tomorrow's award ceremony will make it official, but I wanted to tell you personally, your contribution isn't just significant because you solved the problem. It's significant because you've reminded all of us that breakthrough insights don't always come from the expected places or through conventional methods." Elena smiled, thinking about her humble office back at Westlake, her whiteboard covered in diagrams, her students who had unknowingly helped shape her thinking through their questions and perspectives. "The funny thing is," she said quietly, "I never set out to win a prize or make a name for myself. I just saw a pattern that needed to be understood." "That's usually how the best mathematics happens," Catherine replied, "not in pursuit of recognition but in pursuit of truth." The next evening, with her mother watching proudly from the audience, Elena received the Hamilton Prize, a simple crystal sculpture representing mathematical elegance and a substantial monetary award that would fund her research for years to come. As cameras flashed and the audience applauded, Elena thought about the moment in that ordinary department meeting when the solution had come to her in just 47 seconds. In her acceptance speech, she spoke not of her own achievement but of the beauty of mathematics itself and its power to reveal hidden truths. She talked about the importance of approaching problems from multiple perspectives and of making room in the field for different ways of thinking. And she thanked her students whose questions had continuously pushed her to find clearer, more intuitive ways of explaining complex concepts. As she concluded her speech, Elena looked out at the audience and said simply, "The most powerful solutions are often hiding in plain sight, waiting for someone to look at the problem from a slightly different angle. In mathematics, as in life, sometimes you have to change your perspective to see the truth." The applause that followed wasn't just for her solution, but for the wisdom in those words, a reminder that breakthroughs can come from anywhere, from anyone at any time. All it takes is the courage to see things differently and the persistence to follow that vision wherever it leads.